Welcome to This Explainer. Today, we're unpacking a really mind-bending debate straight from the bleeding edge of modern science. We are looking at the fundamental nature of the universe itself, and specifically, the illusion of gravity. Is the physical world exactly what we think it is, or is it fundamentally different? When you look up at the night sky or literally just drop an object to the floor, gravity feels incredibly intuitive, right? It's just a fact of life. But as soon as you zoom down to the quantum level, the rules get blurry really fast. Let's figure this out together and see if our basic, everyday understanding of reality needs a massive upgrade.
So, does gravity actually come from information? Right now, there's this fascinating, highly technical debate happening among top physicists. They're actively arguing whether gravity, the very thing anchoring us to the Earth and holding entire galaxies together, fundamentally arises from information and statistical behavior. It's a profound and honestly almost unsettling idea. It suggests that gravity might not be a fundamental force in the traditional standalone sense that we learned in school, but rather something generated by the underlying statistical mechanics of quantum information. Think of it kind of like temperature. A single isolated atom doesn't really have a temperature, but a statistical collection of them absolutely does. Could gravity just be the macroscopic result of microscopic information?
Okay, let's dive into this, because our source material today completely shatters those expectations. The author makes a punchy, radical reversal to that current trend in physics, stating simply, we have it backwards. Now that is a bold, foundational claim. If the current consensus views information as the actual creator of gravity, this perspective argues we are literally looking through the telescope from the wrong end entirely. It challenges us to rethink the whole chain of cause and effect. Are we mistaking the symptom for the disease here? The author implies that by trying to build gravity out of information, mainstream physics is effectively putting the cart before the horse. To truly understand why we might have it all backwards, we need to build this argument from the ground up. Before we can even begin to talk about complex forces, fields, or particles, everything starts with the simple act of making distinctions. This is the absolute foundation of reality as presented by the author. Before analyzing gravity, mass, or space, we first have to observe the universe and actually draw a line between one thing and another. For example, in physics, before you can measure any system, you have to mentally or physically separate that system from the space around it. You have to say, okay, this is the object and this is the environment. Making that distinction is step 0. Without that initial separation, there isn't a system to measure, and there's definitely no data to collect. Let's move to and see how this builds, because it's a really organic flow. First, we make a distinction in reality. As a natural consequence of drawing that line, certain physical effects occur. The system behaves in a certain way relative to that environment we just separated it from. And only then does statistics automatically enter the picture, completely defined by that initial action. Do you notice the shift in hierarchy here? The math and the statistical behavior aren't the underlying engine generating the universe. They are merely a byproduct. They just trail behind the physical reality. It's a subtle but incredibly profound shift. The statistics merely track the consequences of the distinctions we've made. They don't push the universe forward at all. They just record where it's already been.
Now, what's really interesting about this slide is how it frames a statistical model. In this context, it's simply a framework established by a set of distinctions, representing how those distinctions behave. Think about that for a second. The model is not the reality itself. It is entirely dependent on the human, scientific act of establishing those distinctions in the very first place. Once we decide exactly how to slice up reality, we gather our data, and then we construct a statistical model of how those slices interact. The model is like a highly polished mirror reflecting the choices we made about what to observe, but it's absolutely not the physical object standing in front of the mirror.
So the crucial point is right here. There is a massive fundamental difference between describing reality and causing it. Distinctions can describe reality beautifully. They're a natural consequence of it. And the source is super explicit here, distinctions cannot be the cause of behavior. Just because we have this pristine statistical model of how our distinctions behave, we absolutely cannot assume that this model literally leads to the physical behavior of reality itself. A model of a hurricane, for instance, is incredibly useful for predicting where the wind is going to go, but the model running on a supercomputer isn't what actually causes the wind to blow, right? The cause is physical, the description is entirely conceptual. We really need to drive this philosophical boundary home. Models describe. They don't cause. Our mathematical frameworks and our statistical models are incredibly powerful tools. They've allowed us to split the atom and send rovers to Mars. But they are consequences of how we categorize the universe, not the creators of it. It's exactly like the old saying, The map is not the territory. The map helps us navigate the terrain, and it represents the peaks and valleys with stunning accuracy, but it doesn't cause the mountains to exist. We have to be super careful not to confuse the equations on our chalkboards with the actual physical engine of the cosmos.
So, what does this mean for gravity? With that foundation set, let's pivot back to that concrete physics mystery we opened with. If models only describe reality and don't actually cause it, where does the physical phenomenon of gravity fit in? If we accept that information and statistics are just the map, then how on earth do we explain the actual physical force that pulls two massive objects together in the territory of real space? While the author uses this entire philosophical framework we just discussed to deliver a very specific, pointed answer to the physics community.
Here is the author's emphatic conclusion, and it is a game changer. Gravity does not come from information or statistical behavior. By applying those logical steps we just walked through, the source permanently flips this debate completely on its head. Because statistics and information are just a byproduct of our distinctions, literally just the map we draw after the fact, they absolutely cannot be the fundamental cause of gravity. The universe isn't some giant computer calculating information to generate a gravitational pull. Gravity is just there, and the information is simply what we extract when we try to describe it. And this brilliantly illustrates what gravity actually is, according to this text. It's ultimately a geometric description of how our distinctions behave. It remains a highly useful concept based on exactly how we slice up reality, specifically into the categories of space, time, and mass. And yeah, for sure, it is automatically related to the information content of those elements. But at its core, it remains a description. It's an incredibly useful tool for understanding how space-time bends and flexes, rather than a literal, tangible, physical force generated by data. It's the language we use to make sense of the universe's geometry. It describes the curvature of the arena, not the fundamental materials the arena is actually built from. Which leaves us with a rather profound question to ponder as we wrap this up. If gravity is just a useful concept describing reality, what other fundamental laws of physics are merely descriptions rather than literal causes? Seriously, if we apply this logic to the rest of the universe, how much of what we call physical reality is really just a mathematical map of our own design? If mass, energy, and time are also just distinctions we've drawn, what is the underlying reality actually made of? Thank you so much for joining me for this explainer, and keep questioning the true nature of reality.